I made a shelf video. I was showing my bookshelves, and somebody pointed this book out. And I thought I had made a video about it, but I don't think I have. I was looking back, and I may have shown it as like one of several books for something, but I've never actually talked about this book in this channel, even though I've had it for a while now. The Geometry of Physics by Frankel. It's got a lot of differential geometry. Actually, I was trying to look it up by differential geometry, and I didn't find it. Then I had to go, okay, fine, I'll go downstairs and look at the physical book itself. I bought it used for a really good price, but when it came, it was spanking brand new, and that is wonderful. I love it when that happens. All right, so let's just go through the table of contents. Manifolds and vector fields. This would be a great book in my case for a return of analysis of R to the N and some differential geometry. Definitely, if I get around to doing that, this would be a great book to look at applications. So tensors and exterior forms, pullbacks. I've read a little bit about pullbacks recently. Integration of differential forms. This is a whole chapter, I believe the last chapter in Baby Rudin. So yeah, just I'll keep that in mind. The Lie derivative. And again, this material is material that I need to cover, so I'm not going to say, oh, and I've done this and I've done that. I have not. The Poincare lemma and potentials, or Poincare, I'm sure I pronounced it wrong, holonomic and non-holonomic constraints. Then geometry and topology, Minkowski space, surfaces in R to the 3, so three-dimensional space. Geodesics, so there's a little bit of algebraic geometry in here as well. Covariant differentiation and curvature. Geodesics, I just said that. Relativity, tensors, and curvature, or curvature. Einstein tensor. Then Singer's theorem, which I don't know anything about. Betty numbers, the Ram's theorem, harmonic forms. This is all really advanced stuff that I have not covered. So I'm just like showing it, and you can pause the video and read it for yourself. You probably know more about this than I do. I'm sure you do, or most people do. Lie groups, bundles, and Schoen forms. Read a little bit about bundles, but it's so far ahead of my progress that it doesn't really matter that I did. Vector bundles in geometry and physics. Fiber bundles, Gauss-Bonnet, topological quantization, connections and associated bundles, the Dirac equation, which I do know about from particle physics. I do know about the Dirac equation, incredibly enough. Yang-Mills fields, Betty numbers and covering spaces, again, way above my level. And then Chern forms and homotopy groups, and then a bunch of appendices. It does not have answers in the back, but it does have references. I go there right now, and I'll page through the book. It's a very thick book. It's got a lot of contents, as you saw from the table of contents. Yeah, so here are the reference pages. Yeah, so it's a lot of algebraic topology. Yeah, very interesting. A great segue to doing advanced physics on this channel when I get to it, which is not, unfortunately, not anytime soon, because I've got so much basic math that I need to cover. So I'll just page through this just so you get a feel for the rest of the book. I'm going to go through these first front matter pages slowly so you can pause the video and actually read the page if you so choose. Yeah, so it's all about the basics of advanced physics, all the mathematics underlying it. Yeah, I think you can pause this and read it. Yeah. And it looks like somebody already read it because they corrected R3 instead of R to the N. I'm sure it's got typos, but it looks very clean for whatever it's worth in my own very ignorant way of looking at it. Lots of explanations, problems. But yeah, unfortunately, no answers in the back. This definitely will be a book that I should cover on my way to algebraic geometry. The Riemann sphere. Now, just out of curiosity, does it say anything about Riemann surfaces? That I want to know right now. And by the way, this is not in the plan for when I was making this video, when I was planning this video. No Riemann surfaces, but other things from Riemann as always. There's always something from Riemann, which is good. Lots of manifolds, change of coordinates, few problems. Not that many, as I was mentioning before. And no, I'm not going to be able to page through the whole book, but I'm just trying to give you a flavor in case you're interested in getting this book for yourself. Scalar products in linear algebra, that's great. Been doing that recently. Brackets. Yeah. So it's got a lot of nice figures, as you can see. And lots of words between the equations. I'm not seeing as many examples, but I am seeing proofs, which is wonderful. Be on the lookout for more proofs. But yeah, it's not what I would consider a good book for self-learning, in my opinion, because it doesn't have that many examples. It does have some proofs, but it does not have answers in the back for simple problems. It doesn't have simple calculation problems for which there are answers in the back. I would have loved that. But of course, the book is gigantic, as you can all see. Yeah. And I'm going to page through ahead just so you can see the different parts. Wedge products, the different parts of the book. But yeah, beautifully illustrated. This is the geometry and topology part 2. Minkowski space. This is the tie-in to special relativity. I remember some of this from Jackson Classical Electrodynamics. Has a really good section on relativity. This is tie into, I think, differential geometry. Gauss gets mentioned. But yeah, just tons and tons of content in this book. A great book, I think, to do with other books that would have some answers for babies like myself. And I'm not doing this book justice because it is so long and it's got so much content. But I'm trying to page as much of it as possible without making a super long video, so you can see that the author really went all out. I mean, it feels like 4 or 5 books in one to me. Bundles, all about vector about bundles. Yeah. Yeah, so this is all really advanced material in my opinion. There's direct equation, great stuff. Spinners, Yang-Mills. Yeah, see, these are really good diagrams. Okay, so I think I'm going to stop there, but as you can see, there's a lot in here.